Good evening. So today we are going to start surface chemistry, our next chapter, that is chapter number 5. So let us start. Is it okay now? दिख रहा है बेटा? Okay. तो सरफेस केमिस्ट्री होती क्या एक्चुअली में? इट इज रिलेटेड टू सरफेस, केमिस्ट्री ऑफ द सरफेस. जैसे सबसे पहला जो टॉपिक है दैट इज एडजॉर्प्शन. फर्स्ट टॉपिक इज एडजॉर्प्शन. अब दो टर्म्स है, देखो, एक एडजॉर्प्शन, एक एब्जॉर्प्शन, और तीसरी है सॉर्प्शन. टर्म्स एडजॉर्प्शन, एब्जॉर्प्शन एंड लास्ट टर्म इज सॉर्प्शन. तो तीनों टर्म्स का हम मीनिंग पहले चेक करते हैं, व्हाट डू यू मीन बाय दीज टर्म्स, और उसके आगे बढ़ते हैं, है ना. अब एडजॉर्प्शन क्या होती है? इट इज अ सरफेस फिनोमिना के सरफेस के ऊपर, जैसे देखो ये मैं दिख रहा हूं, ये जो इंक है दैट इज एडजॉर्ब्ड ऑन द सरफेस ऑफ द व्हाइट बोर्ड. व्हाइट बोर्ड के सरफेस के ऊपर जो है ये इंक आ रही है. इट इज नॉट गोइंग इन टू इट, इट इज ऑन इट्स सरफेस ओनली. concentration of this ink particle is more on the surface than in the bulk. But यही ink, if I poured in water, then that ink is uniformly distributed. थ्रू आउट इन द बल्क. अगर वो इंक मैं वाटर में डालता हूं तो दैट इज कॉल्ड एब्जॉर्प्शन. क्या बोलेंगे इसको? एब्जॉर्प्शन. तो एब्जॉर्प्शन में क्या होता है कि जो कॉन्सेंट्रेशन है इज सेम थ्रू आउट द बल्क. Concentration is same throughout the bulk, but in adsorption concentration is more on the surface than in the bulk, right? तो adsorption में दो जो मेन पॉइंट है, दैट इज one is adsorbent and other is adsorbate. अब we are talking about the ink and whiteboard. Now whiteboard provide the surface. Whiteboard provide the surface. So in this case, whiteboard is an adsorbent and ink, black ink, is adsorbate. The substance which is adsorbed on the surface, that is called adsorbate, and the substance which provide the surface for adsorption, that is called adsorbent. Done? Any doubt in it? I think it is clear to you what is adsorbate and adsorbent. Means adsorption has two terms. One is adsorbent, other is adsorbate. Yes, beta. Any doubt up to this? Okay, great. Okay, Kerala fan, thank you. Okay, now if we are talking about absorption, so simple example is ink in water. So ink is uniformly distributed, and in absorption, rate of reaction is same throughout the process, but in adsorption rate is more in the beginning, but slowly it will decrease. Reason being, it is related to active sites. Surface has a calculated number of sites. Surface has calculated number of sites. If those calculated number of sites are filled by the particles, then adsorption becomes slow. That's why adsorption is fast in the beginning and then becomes slow, but absorption remains same throughout the process. Sorption. Last term is sorption. Sorption means when adsorption and absorption takes place simultaneously. When absorption and adsorption takes place simultaneously, then that term is called sorption. So three terms we have done. First is adsorption, second is absorption, and third one is sorption. I think all the three terms are clear to you. You can get the difference between adsorption and absorption. Okay, so let us discuss the difference between absorption and adsorption. So difference between adsorption and absorption. So adsorption means concentration of species or substance is more on the surface than in the bulk. In this case, in absorption, concentration of the substance is same, or we can say uniform, throughout the bulk. Means concentration is uniform throughout the bulk. Second difference is adsorption is surface phenomenon, but absorption is bulk phenomenon. Third, rate of adsorption is high in the beginning and then decreases. In this case, the rate of absorption is uniform, or we can say same throughout the process. Okay, so these are the factors, or one more factor you can add, that is in this case substance is distributed throughout the, in this case when distribution of substance takes place, distribution is different on the surface than in the bulk. That is also covered here. In this case, distribution of the species is same throughout the material. Okay, so this is the difference between adsorption and absorption. Yes beta, any doubt up to this in this process? Okay, so we will go ahead. Focus. Now, when this substance is adsorbed on the surface, then that adsorption on the surface may be forming chemical bond between adsorbate and adsorbent. See, we have adsorbate and adsorbent. ये दिखाई दे रहा है बेटा अच्छे से? बेटा अच्छे से दिखाई दे रहा है? स्टीफन मैथ्यू बेटा ओके MnO4 negative in it is oxidizing agent and I2 is reducing agent. Okay, now adsorbate and adsorbent. Adsorbate and adsorbent, when there is a chemical bond formation or sometime there are van der Waals attraction. On the basis of interaction, they are divided into two categories, that is physical adsorption or chemical adsorption. Physical adsorption and chemical adsorption. So what is the difference between physical adsorption and chemical adsorption? That is very, very important question. There are so many times this question asked. What is the difference between physical and chemical adsorption? Or it is known as physisorption. It is also known as physisorption or chemisorption. Okay, physisorption and chemisorption. Now, in physical adsorption, there is a weak van der Waals attraction between adsorbate and adsorbent. There is a weak van der Waals attraction between adsorbate and adsorbent. In chemisorption or chemical adsorption, there is chemical bond formation between adsorbate and adsorbent. Okay, in first case there is a weak van der Waals attraction, in second case there is a chemical bond formation. So you know, when adsorbate and adsorbent they interact with each other, energy is released, and that energy is called heat of adsorption. What is called it as? Heat of adsorption. So tell me, heat of adsorption for physical adsorption is low or high? Yes, beta. Heat of adsorption, is it low or high? Respond fast. Very good, Anika. It is low. So because there are weak attractions, so energy released is less. But in the case of chemisorption, heat of adsorption is high. In chemisorption, heat of adsorption is high. In physisorption, heat of adsorption is low. Third case, effect of temperature. You know, in case of physical adsorption, attractions are weak. So when we increase the temperature, what would happen? Those weak attractions break. Those weak attractions break. So when these weak attractions break, then adsorbate and adsorbent get separated, and this is called desorption. What is it? That is called desorption. That means adsorption, in case of physical adsorption, adsorption decreases with temperature, with increase in temperature. That means if we increase the temperature, adsorption decreases. If we increase the temperature, adsorption decreases. Wait, I will. Okay, but in case of chemisorption, there is a chemical bond formation, so a small amount of energy is required to form a bond, and if and temperature is very high, then bond breaking takes place. That means in this case, adsorption increases, then decreases with rise in, with increase in temperature. That means if we plot the graph, then graph in this case x upon m versus temperature. So graph is like this. X is amount of adsorbate, m is mass of adsorbent, means mass of adsorbate per unit mass of adsorbent versus temperature. In case of x upon m versus temperature, first it increases and then decreases. First it increases, reaches a maximum, and then decreases. Okay, so first of all, adsorption increases with rise in temperature, reaches a maximum, and then decreases with rise in temperature. So this is the graph for, and this is called adsorption because it is at constant pressure. So this is adsorption isobar. This is called adsorption isobar. This is adsorption isobar for chemical adsorption, and this is adsorption isobar for physical adsorption. Done. Now, say this heat of absorption is low and its order is 20 to 40 kilojoule. Here it is between 80 to 240 kilojoule. And if it is between 40 to 80, that is a mixed type of adsorption. Means physical as well as chemical. Both type of adsorption takes place. Okay. Beta, organic chemistry we will start after this chapter. After surface chemistry. Okay. Now third point we have covered. Now fourth. In case of physical adsorption, multi-layer formation takes place. Because For chemical bond formation, adsorbate and adsorbent should be in contact with each other. If they are not in contact, there should not be a chemical bond formation. That's why in case of chemical adsorption, only unimolecular layer is formed. Means in chemical adsorption, only unimolecular layer is formed. But in case of physical adsorption, multi-layer formation can take place. Like if this is the surface, so molecules which are in direct contact with it, they can form chemical bond. But what about the particle above it? They are not in direct contact with the surface, so they are not able to form a chemical bond. They can interact only by van der Waals attraction. So second layer, third layer, fourth layer can be formed, but that will interact with the surface by weak van der Waals attractions only. They will not be able to form a chemical bond. That's why in chemical adsorption only unimolecular layer is possible. Multi-layer formation does not take place. Right? Next, point number 5. Physical adsorption, it is non-specific. Non-specific means, what do you mean by non-specific? Non-specific means if adsorbate and adsorbent, any kind of adsorbate or adsorbent can interact, but in the formation of chemical bond, they should be specific. They should have ability to form a chemical bond between them. So chemical adsorption is specific, physical adsorption is non-specific. I think I am confused with the spelling, but it's okay. It is non-specific and it is specific. So did you understand what do you mean by specific and non-specific? Specific means specific pair of adsorbate and adsorbent can form a covalent bond or ionic bond. Chemical bond formation takes place. But in case of physical adsorption, any two adsorbate and adsorbent, if there is no force of attraction, at least van der Waals attraction should be there between two substances, right? But for the chemical bond formation, they should have the ability to share electrons or to donate pair of electron like that, okay? Physical adsorption, it is reversible. Why is it reversible? Because physical bonds, they can easily break. Van der Waals attraction can easily remove. If they come closer, there is a attraction. If they go away, attraction dissipate. But once a chemical bond is formed, it is very difficult to break it. If it is very difficult to break it, that means this type of bond is formed permanently, right? So chemical adsorption is irreversible. Okay, and for the formation of chemical bond, activation energy is required. So there is a concept of activation energy is required. But in case of physical adsorption, there is no need of activation energy. Now, ease of liquefaction. You know, if gas is easily liquefied, that can stay on the surface of adsorbent. That can stay on the surface of adsorbent easily. So, easily liquefiable gases can adsorb easily, or we can say readily. But in this case, in chemical adsorption, chemisorption, easily liquefiable gases has no role to play in this case. In this case, easily liquefiable gases or not, but they should have the ability to form a chemical bond. Then chemisorption takes place. Yes, beta. Any doubt up to this? Yes, beta. Any doubt up to this? Okay. So in this case, one more we can write that in this case no change in state. State remains same because there is only weak van der Waals attraction only. But in this case, there may be quite different, means no change in state, or we can write state, physical state, okay? State is same as in bulk, but here surface there is a formation of chemical bond, so there may be a quite different state as in bulk. So these are the points. You can write any 4 points while doing the question in the exam. Reason being, this question is asked for 2 marks, so you should write at least 4 points. If question is of 1 mark, you should write 2 points of difference. If question is of 2 marks, you should write 4 points of difference. Okay? Now let's go for its thermodynamics. Thermodynamics of adsorption. So in thermodynamics of adsorption, you know, this is the formula, delta G equal to delta H minus T delta S. Delta G equal to delta H minus T delta S. First thing, keep in mind, adsorption is always exothermic. Delta H is always negative. Adsorption is always exothermic. Why is it exothermic? Because whenever adsorption takes place, there is force of attraction between adsorbate and adsorbent. So as there is a force of attraction between adsorbate and adsorbent, that's why there is a release of energy. That's why delta H is always negative for adsorption. So first factor which is in favor. And second thing, adsorption is always spontaneous. Adsorption is always spontaneous. That means because if it is taking place, then delta G is always negative. And adsorption leads to decrease in randomness because molecules are fixed on the surface. That's why adsorption leads to decrease in randomness. That's why delta S is always negative. Delta S is always negative. See, delta H is negative, delta G is negative, and delta S is also negative. All the three things, delta H, delta G, delta S, all are negative for thermodynamics. Okay, so that's all for today. Tomorrow we will do friendly adsorption isotherm and applications of adsorption. Okay, thank you. Any doubt up to this? Yes बेटा, ऑर्गेनिक करेंगे हम आफ्टर दिस चैप्टर. Okay, then bye bye beta. Thank you all.